Let's discuss about momentum. So we'll approach it by understanding it a bit and then defining it. Okay. So we'll understand with this set of scenarios and experiments. The first scenario is this issue of space debris. First thing is, what is space? This is Earth. After certain height, we define that region and above that region to be space. Debris is nothing but junk. So space debris are nothing but the junk that is in space. So what is the issue because of them? Even tiny paint flake traveling at an orbital speed can damage a spacecraft or destroy a satellite. What does it mean? First thing is, we'll understand orbital speed. This is Earth, and say we have a debris going around the Earth, right? It has to have a certain speed, and that speed we're calling it as orbital speed. If the speed is less than that, it will fall onto the surface of the Earth. More than that, it takes a different path, but that particular speed, it goes around the Earth without falling into the Earth. So an object as small as a paint flake. Paint flake is nothing but paint that comes out of a vehicle or anything. That's a small thing, is it not? That thing can damage satellites, destroy them as well, it seems. Right? So why is that? Because of the speed it has. Because of the speed it has, even though it has a very small mass, it's able to damage a satellite, a spacecraft, and destroy a satellite as well. So there are a few examples. Let's discuss that. A number of space shuttle windows were replaced because of damage caused by material that was analyzed and shown to be a paint flake. So this is real, this is not some hypothetical thing. This is real. It has happened. You can web search this space shuttle window destroyed by paint flake. It's a interesting bit. Please do search that. We're talking about a very small thing which can damage glasses which are bulletproof, right? So look at the energy it has, look at the strength it has. So web search this. I hope you guys did this. So there are scenarios, there are real examples wherein a small paint flake has damaged windows which are really strong. They're not some ordinary windows, they're really strong, right? One more example. In 1996, a French satellite was hit and damaged by debris from a French rocket that had exploded a decade earlier. So around 1986, a satellite or a rocket had exploded, and the debris from that happened to damage a satellite. Again, this is an example. There are many examples out there. You can learn about it by searching that. Now, I have a question with all of this understanding. I have a small question for you guys. I have two JCB to be accurate, which has the same mass but traveling at different velocities. If they do hit something, which will create more damage to that? Which is more dangerous? Obviously, this, right? Let's see this experimentally. So what did we see? We had two marbles, and both the marbles had same mass. That's mass 1, mass 2, mass 1. Both have the same mass. Both were left from this plank, but one was left from point A and another was left from point B. So the velocity they attained by the end of their journey along the plank is different. So obviously, the marble left from point B had more velocity than A. And thus, the marble from higher velocity created or destroyed the structure a lot more than the one which had lesser velocity, is it not? So basically we can observe that marble with higher velocity is more destructive than marble with lesser velocity, right? So this is your observation from that particular experiment. Next scenario is this. We have same speed, two things traveling at the same speed, but obviously this is way smaller, say a marble. So the marble one is of a lot lesser mass than a JCB, but traveling at same speed. Again, the question is which will, if they do hit something, which will damage the most? If JCB hits something with this particular speed compared to a marble, obviously this will damage something, any object, a lot more than a marble. So let's see this experimentally. So in this, we have three objects of different mass left from the same spot. All of them by the end of the journey along the plank will have the same velocity. At this point, they'll have the same velocity, almost the same velocity. Of course, they'll continue to go and hit the structure. So you guys have to observe which will damage the structure more. So please have a look at this. So what did we see? We saw that the billiards ball damaged the structure more since it has more mass, right? So to conclude, an object with more mass is more destructive than an object with lesser mass but with same velocity, condition being having the same velocity, right? So overall, what can we conclude? We can conclude that it's tough to stop an object with higher mass or higher velocity or an object with higher mass and velocity, right? Is it not? It makes sense. If something is approaching you guys, like say a small kid on a cycle, slowly if they approach you, you guys don't get scared that easily. But if a car is approaching with that velocity also, you tend to get scared, is it not? Why? Because it has more mass. So mass and velocity determines how tough it is for us to stop something. And that is nothing but your momentum. Mathematical expression which refers to this state of an object is your momentum. So this is a particular state that the object is in. It has a particular velocity, it has a particular mass, it has a particular damaging capacity. That damaging capacity is what we're calling it as momentum. Okay. So in time we'll define it and represent it with a mathematical expression. Okay. So for now, I want you guys to pause, look through whatever you find to be interesting and easy to make a note of. Please make a note of that. Okay. And please do web search space shuttle window being damaged because of paint flick so that you understand the idea of momentum better.